Let me share my screen. Share my screen. All right, can everybody see my screen? I imagine so. All right. Okay, let's see. Welcome. This is the third week of database design. Let's see in the chat. Everybody, okay, everybody says yes. Good. And the focus of this week will be to start implementing databases. We've spent a week or so talking about designing databases. The first week that we met, we talked about installing the tools that we need, such as Workbench, and installing the database server, MySQL server. Second week we did design, which just completed last week, and I believe there's a design assignment that is due tonight. And so today we're going to introduce the third assignment about creating, or also we say that we realize the database, and we're going to create the database. And it'll entail the fact that we want to be able to convert the class diagrams that we have designed with nice pictures and nice boxes and arrows and lines and whatnot. We need to convert that into something concrete, into an actual database. Where we need to know how to convert those diagrams into tables, right? Into a relational model. So we have a conceptual model, the UML class diagrams. We're going to convert it into a relational model. Relational model because we are building it with a relational database. Okay. So just before we get started, just want to reiterate a couple things. We do have access to the syllabus here, right? And we are following the agenda listed there. And so again, we have a list here of all the instruction team, all the TAs and their office hours. So please feel free to visit their office hours. The links to various Zoom meetings that we're meeting. So today, right now we're meeting at 1:35, but if you prefer to meet at 3:25, that's totally fine. Or if you prefer just watching this remotely and asynchronous whenever, hopefully it's within the same day or within 24 hours. There might be some messages in the lecture that might be some time sensitive. So please do not binge watch these videos, right? Make sure that within reason, depending on whatever circumstances that you find yourself, depending on the time zone or geographically, or whether you work or not, please make an effort to stay up to date and take a look at all these lectures. So we are following this agenda. The first week we met to talk about installing a database, and that was the first assignment. The second assignment that is due today is about designing the database. So we spent a week talking about drawing class diagrams and boxes and lives and properties and whatnot, right? So this week we're gonna take a look at, say, well, now that we have several class diagrams, let's convert that into a relational database, right? We're gonna use the create table command in SQL to create the actual table, okay? Also, we do have a quiz later this week on Friday. Again, all quizzes. I know I had said that I wanted you to be at the during the lecture, that we're going to do the quizzes during the lecture, but I have changed that requirement. Instead, the quiz will be available February 5th, right? This coming Friday, from the morning, early morning, all the way through Friday midnight, and then again on Saturday, right? So that's that's 48 hours that you have to do the quiz. Obviously, the quiz are meant for you to do on your own. Many of these questions are random questions, again, to help mitigate the fact that to discourage you from trying to collaborate, right? Ideally, you're gonna do this on your own, at your own, whenever you have time. And it's open book, right? So if you familiarize yourself with the slides and with the lectures and the assignment, you should be totally fine taking those quizzes. Question on the chat. Can you go over which lectures we should focus on the quiz? Yeah, so it's about design. So DB, the quiz number 1 is about design. So all about UML class diagram. So make sure you understand one-to-many, how to implement many-to-many, how to do a reification, right? If you have 2 classes that there's a many-to-many relationship in UML, you can have a line, right, and star on each side. But to reify that, right, remember we add a third table in between, a third class. We converted it from a one many-to-many into 2 one-to-manys, right? And the strong relationship is on the original tables, right? And the weak relationship, the stars, right, is on the new table. Okay, so make sure that you understand that. Is the quiz from Friday morning to Saturday night? Yes, exactly. From Friday morning all the way to Friday midnight, Eastern time, right? I don't know whatever that is at your geographic area. So make sure that you understand, right? It's open. It is timed. I believe it's 30 minutes, something like that. And there's 4 questions, 4 or 5 questions. So you should have plenty of time to complete the quiz. It's all of them multiple choice. Okay, so only stuff from week 2, not 1 or 3. Exactly. Everything that we covered last week, UML class diagrams, right? So again, many-to-many, one-to-many. Make sure you also know aggregation and composition. You know the difference between the 2, right? That you know how to draw those diagrams, okay? Or you know how to pick which one is aggregation, which one is composition. Things like that, right? That we covered last week. All right, so that's the quiz is going to be this Friday. It'll be available Friday morning till Saturday at midnight Eastern time. So let's talk about the 3rd assignment. Let's see, any other administrative thing here? Let's see. Right, remember that we're using Piazza to communicate. Please, any communication, please stick to Piazza. I mean, you can send me emails, but for me, it's better if we keep all of this course inside of Piazza. If you have to send something private, just send a private message to myself or the instructors, and so that we can all keep an eye on the communication. Obviously, you have the lecture links for both sections, and I've been adding all the videos to a playlist. Or you should definitely subscribe to my YouTube channel and click the bell to be notified whenever I upload new videos, so you can watch them right away. And they should be available shortly after the lecture. So yeah, office hours are listed here. You can link that. And these are week 1, week 2, and here we are at week 3. So let's talk about the database, creating databases. Let's talk about that data, that assignment. All right, so creating relational databases. All right, let's see. So let's see. So the last week we started working on designing the database. We talked about creating the user class, right? And I believe I had you work on the blog class and the rating class and the reply class, right? And some of them I gave you, some of them you worked on your own. I just realized that this is the answer to the previous assignment. So there you go. So this is the answer to tonight's the homework that is due tonight. So there you go. So anyway, so this is the design that you worked on in the previous assignment, and today we're going to start playing around with this. How would you actually implement this in a relational database, right? So we're going to be using the create statement in SQL, right, to create this user table. Then I'll create a couple of these, right? And like always, right, there will be a portion where I do it, right? And once I handhold you and you see me do it, right, then you go ahead and do it yourself, right, with something else, right? So for instance, I'll ask you, I'll create the user table for you, and then I'll ask you, well, create now the blog table. And then I'll create the reply table, and then ask you that to create the rating table, and so on and so forth, right? So we'll team tag here, or tag team, tag, whatever. Sorry, English is not my first language. All right, so let's create a couple of tables. I'm going to demonstrate here in today some live coding, so just to demonstrate what it is that we're expecting of you. So first of all, we're going to ask you to create the user table. Okay, we give you here the SQL statement that creates the table, and so let's take a look at it. Right, so notice that this is assuming that you have a database called DB Design, right? So I believe I have that. I do have, yeah, DB Design, and so, but actually, I'm going to, yeah, I'm going to create a separate schema that is specific for this section, right? I'm going to call it DB Design, and I'll say section 303. Okay, so I'm going to apply. Okay, there we go. You don't have to do this, right? You can use the DB Design that you created the first week, right? I think the first week I asked you to create a couple things. I think I even asked you to insert a couple things in there. I think it's a couple users, Alice and Bob. You can keep using that, right? You don't need to create a new one for every assignment, okay? You can just stay and use the same database, right? So here it is. So right now there are no tables here. So let's, I'm gonna double click it so that it becomes the default database, okay? All right, now I can close this. Close that. All right. And to execute this, I can open up a brand new SQL screen over here, a new SQL a window, right? And in that window, I can create, let's see, is there a question on the chat? I have a question about the diagram in the assignment for the relational model blog and posts. Why is the many on the side of the blog? Oh, is there a typo? Let me see. Many on the side of the blog. Ooh, this is wrong. Yeah, good catch. Yeah, this is supposed to be one to many. So one here and a many there. Good catch. I'll fix that. Thank you. Yeah, if you remember in the assignment, I had asked you that it would be a user has many blogs and then one blog has many posts. So the one here is on the blog side and the star is on the post. So there's a one-to-many between user and blog, and then a one-to-many between the blog and the post. Whereas the reply and the rating, they implement many-to-many, right? So that's why you have a star and star on the side of the reply. Very good catch. Thank you. How do you know to make the loop on reply? How do you know to make the loop on the reply? The loop on the reply is, and so we're going to cover that today. But the idea of making loops here that that a table has a reference to itself allows you to create hierarchical data structures, right? So pointers, right? It's like a class that has inside one of the properties is a class itself, right? So for instance, you might have a product or category. Say you have a class category and you want that category to be able to have subcategories, right? So the way you could implement that in Java is that you have a variable, a class variable inside of the class that has a self-reference, references itself. And that what allows you to do is create, pointing to your parent, right? And your parent can point to their parent. And then at the top, you have a root of this tree, and the root has no parent. And that's how you know that you are at the root of this tree, right? And then you can create any number of hierarchies. So this is what allows you to do also in relational databases. If you want to create hierarchies of people replying to replies to replies to replies, so you can have like a hierarchy of replies. Okay, say, let's see on the chat. We don't actually need topic and follow. Not for the assignment 2. No, not for the design. We will be adding them as we go. Do we need a loop for the homework due today? No, I do not believe so. I do not believe the loop is for this for homework 2. We will be adding it to homework 3, which is the one we're going to be working on. All right, all good questions. Awesome. Yeah, so let's get back to the assignment. So the assignment here gives us the beginning of a user table. Now, we can create a user table 2 ways, right? I know already how to create it by hand, by actually typing this. I can just copy this, and I can come over here, and in a brand new SQL screen, I can open up a new SQL screen right here, new. I can just paste this. I can paste this. and I can run this. If I run this, it says that it's no good. Oh, right, because I don't want to do this I don't want to do this in this schema. I want to do it in my DB design 03. Notice that I don't need, right? I could say 03 here, right? Because that's where I want to create this table, right? If I select and I run it, okay, there it is. So it creates it. And if I open it here, if I refresh, there is my users table with all the columns, right? All the columns, the ID, the first name, the last name, and there they are. See that? Okay, perfect. Or let me remove it. I can remove it by right-clicking and saying drop table. I'm going to show you multiple ways of doing the same exact thing. All right. It's often the case that that you can do things multiple ways. So notice that DB design, I double-clicked it. So now it's the default schema, right? It's the default database. So you don't really need to specify what schema you want to work with. Okay. Well, I mean, you can say use, and then the schema that you want to use, right? The what is it? DB underscore design underscore 03. Okay, so you can specify that all the commands that are following are within the context of that schema, right? And notice there's no table there, right? There's no table. And if I run this, right, it creates the table again, hopefully. There we go. There's our user table, okay? And with the columns. So that's good. But because I double-clicked on this, because I double-click it, you see it's bold. See that? It's bold and not the other ones. That means that I don't really need this use. I don't really need the use. I can let it go, and we understand that it's within the context of the current default schema, this will execute, right? So if I drop this, I throw it away, drop the table, okay, and I'm gonna run it again. It runs again, and now I have the table again. Maybe not. Let me run this. Let me refresh. There's the users, okay, with the columns. All right, excellent. Now, how do I even wrote this? Okay, how do I wrote this? Well, I mean, I could be a really good SQL developer, and I know all these by heart and whatnot, and and certainly we could totally do this, right? But you can do this graphically too. You can do this graphically, and let me show you how you would do it graphically. Let me drop the table again. Drop the table. Drop the table. There we go. It's gone. Let me show you how you can create this graphically. So you can select the tables here, and you can say new, create table, or there's a create table right here. See that? Right. So if you can click on that, it creates a new table, and it opens up a table editor. Okay. And so what do we need? Let's see. We need we definitely need a primary key, right? So the table we'll call it users. Okay. And the ID. And I'm going to say that this is by default, the first field by default, it's assumed that this is the unique identifier that will uniquely identify all our records, right? So notice that it sets it as the primary key, and as an integer. So that's by default, but you can change that. You can override that to be something else. But basically what we want here is that we want it to be a primary key and not null, right? Meaning it's required. And it's auto increment, meaning it'll start at 1, and then every time you insert something, you don't have to specify the ID, right? It'll auto increment and become 1, 2, 3, 4, and so on and so forth. Okay, what are the fields that we need here? We want first name, last name, username, password, profile picture, blah, 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 blah. All right, so first name. So I'm going to go first name first. Now, I could use this camel casing, but SQL is case insensitive, right? It's case insensitive. So it's going to ignore the fact that I made this capitalized, right? The tool will remember, right? But the language won't care. So what we typically do is that we use another casing strategy. We use the underscore name like that to separate words, right? So that it's readable. It would be hard to read if there are no spaces or no underscore or no capitalization. So that's why we put underscore, right? That's and now it's a string. I'm going to go with 45 characters. It's the default. I'm going to take that. I'm going to leave that. It's good. Also, I'm not going to say not null, maybe you know, if you create an account, usually you don't require the person to have the first name, maybe just a username, maybe that's required. But later on, you can have folks enter their first name and last name. So I'm not going to make it not required. Also, it's not a primary key. So that's the first name. Let's do a couple more. So last name, right, varchar, and we have maybe a username. So username, that one probably should be required, right? Not null. And password, probably that one's also required. What else do we have here? Profile picture. So profile picture, varchar, that's not required. And what else? Then we have created and updated. So created. So created, I'm going to go with date time. Okay. Date time and updated. So these two, I'm going to be using them so to kind of keep track of of anything that happens to a particular record, right? As I insert new records, I would like to know, when was this record created at first, right? And if anybody changes anything here, maybe they change the password or they change the profile picture, I want to keep track, when was the last time this record was updated, right? So these are two fields that I'm going to use for that, right? So how do I do that? How do this configure, right? So this is already configured as a primary key, right? So I will have created all this, right? Plus the ID is a primary key, but not these, right? I want date time. Initially, they can be null. I want to have a default value, right? So that the created, right? You can specify that when it gets created. If you don't specify a value for create, if you don't give me a date time, I'm going to go with the current timestamp, right? I'm going to grab the clock, right? The system clock, right? I'm going to grab that as a value for created. Whereas update also is going to have a default value of the current timestamp. But in addition to that, I'm going to have an update current timestamp. And what that means is that if this field updated, if it gets updated, then I want the value to change to be the timestamp of whenever this was updated, right? So how do we do that? Well, notice here we have default. See that? We have default. So for created, if I double click here, there's you can start typing the default. Why is it not selecting? Usually it selects. So default current. Why are you not? Default. Escape. Well, I guess I'll copy from here. Default current timestamp. Current time stamp. Okay, current timestamp. Okay, that's it. Indices, foreign keys, trigger, partition, options, date time. Oh, there it is. Defaults. There it is. Default. Okay, perfect. And this one update is going to be current timestamp on update current timestamp. So I'm going to paste that in there. Okay. All right, there we go. I'm going to enter that. Okay, perfect. So what I'm saying here is that the created is going to have a current timestamp when it gets defaulted, right? When it gets created, and then the update is going to also have a default current timestamp. But on update, if it gets updated, I want to re-update it to the current timestamp again. Okay. All right, I think that's it. Let's. I think I don't have anything else. Let's see. We got the primary key. We got the auto increment. We got the not null for ID. All right. I think we made an improvement here. Not null. Not null, meaning we're making this username and password, we're making it required, meaning if you try to insert a record that does not have a username and doesn't have a password, I'm not going to allow it, right? Those are absolutely required. Chat. Timestamp doesn't have an underscore in it. Timestamp. Oh, yes, thank you. Yeah, no underscore right here. And this one also, current timestamp. All right, current timestamp. Blah, blah, blah. All right, perfect. Thank you. And we can apply. Now, if we apply this, notice that it writes for us. It writes for us the command that it's going to run to create the table, right? If I apply, it says okay. We close that, and we can absolutely see here that it creates the users. All right, so many ways of implementing the tables. You can absolutely use this this graphical tool, and what it does is basically a graphical tool that writes the SQL for you, right? You can absolutely just write the SQL in a SQL window like this, right? Which is basically what we're going to ask you to do in the assignment. But you can absolutely use the SQL this graphical tool to do this. Okay, so once you implement this, once you implement it, we are going to ask you to save each one of these into a specific file. Okay, so for instance, once we have this, we're going to ask you to save, and in let's see if we can go NEU and 2021 spring 3200, and I'm going to say DB3. So I'm going to say DB3. In here, I'm going to save it into a file that's called create user table. Okay, and you're going to submit this, right? This is what you're going to be submitting in the assignment. And save that. Perfect. All right, excellent. So that's easy because we gave you that one, right? Over here, there's a whole bunch of discussion that I have here. Why we named first name, we use underscore. I explained that to you. Why we did that, because it's case insensitive and all that, right? Question: how do we find the code if we made the table manually? Oh, when we created the table and we said it comes up, you know, after we did this, and we said apply. Well, it's too late. It opens up a diagram, right? It opens up the SQL code, and there you can copy it. And also, if you missed it and you forgot to copy it, you can always go back to the user table, right? And you can say copy to clipboard the create statement. See that? The create statement, and then you can paste it inside an editor, and there it is. Right? You can always bring it back. It adds this stuff at the bottom. This here. You can leave it. That's fine. It's internal for internal purposes. You know what kind of internal engine is using for querying the database. Okay, so you can totally retrieve it by again saying users, and then either copy to clipboard, or you can send it to the SQL editor, right? So for instance, if I'm down here and I can say send it to SQL editor, the create statement, it copies it into your editor. Okay. All right, excellent. So let's keep going. All right, so then we ask you to implement the one-to-many relationship between the user and the blog. All right. So first we do it for you. Again, we're going to do this one for you. We're going to do this one for you, the one-to-many. I'm going to grab that. I'm going to copy this. I document each one of the lines here. You know, the NUC identifier, the primary key. Now here the created and updated. So all my tables are going to have this created and updated. Yes. Now what we're going to do here is that to implement the one-to-many, right, in SQL, the way it's implemented is by having a foreign key, meaning the blog is going to have a field that is going to have a reference back to the primary key. Notice that it's not listed, it's not shown in the UML diagram, right? Remember, right, that in the UML diagram, the way we document one-to-many is by this line, right, by this association line that says that it's one-to-many. That already implies that if you're going to implement this in a relational database, you're going to need a primary key on the user table, and you're going to need a foreign key on the blog. Yes? And here it is, right? Notice that the blogs table, also notice the naming convention, right? In UML, because it's object-oriented, classes are nouns, and they're singular, and they're capitalized. The first letter is capitalized. Whereas in relational databases, the tables usually are also nouns, you know, just like in the class diagrams, but they are plural. right? It's a good practice to use plural names for the names of the tables. And also it's all lowercase. And if it's 2 words, you would use underscore between the 2 words. All right, so the way we implement this is with a primary key on the user and a foreign key on the blogs. And here's exactly what we have, right? So here we have the name, right? The topic, the created, the user, and the updated, right? All the fields here. Plus, we're adding user. See that? That user is going to be our foreign key. That's how we point from the blog. We're going to reference the user that we belong to, right? And that's going to implement the one-to-many. So here's our user. It's going to be a foreign key. There it is. See down here? I'm going to say this is a foreign key user, which is referencing the users table primary key ID. See that? I'm also going to say that on delete cascade, right? And on update cascade. What that means is that this is actually going to be a composition, right? We're implementing that as a composition, meaning that if we remove the user, then the blog should go away as well, right? I don't want to keep the blogs if the user goes away. Or if the primary key of the user changes, right? My primary key was 1, 2, 3, and it changes to 2, 3, 4. Well, that should propagate down to the foreign key, right? So that if your primary key changes, well, mine should change as well. So I still keep pointing to the right user. Okay, so that's what these cascade commands do. So let's copy this. Let's copy that. So to create the blocks table, let's paste that. Okay. Oops. There's some typo here. Primary, blah, blah, blah. Create, timestamp, yada, yada, yada. On update, what's wrong with this? Current timestamp. Oh, I think I have an extra parentheses here. Yeah, I had an extra parentheses. All right, so let me remove this extra parentheses here. There we go. All right, so let me select this. Also, let me remove the schema here because I'm using by default my DB design here, and we're going to run this. I'm going to select the whole thing. We're going to run it. Okay, and let's see. Let's refresh. There we go. And we ask you to save it in a create blog SQL. Okay, so we gave you 2 tables. Right? We gave you 2 tables. Let's save that. There we go. Now we ask you to do one for you on your own. Chat. There is an extra. Oh yeah, yes, thank you. Yeah, we fixed that. All right. So having done this for you, right? We ask you to do that on your own. Okay, here I have like a small little blurb about how to do this graphically. Okay, and now so if you're okay with doing it at the command line, at the using at the window and typing it away, that's perfect. So you can skip this part. But if you want to learn how to do it graphically with the tool, then go ahead. I have a little blurb here telling you how to do that. So here. Now we're asking you, okay, this is correct. See that now? This is a one-to-many. This is correct. See, one-to-many. Over here, it's supposed to be one-to-many as well. Right, this is supposed to be one-to-many over here. Okay, so that's wrong. Actually, can I fix that? No, I can't fix that. All right, I'll fix it later. So we ask you that, having shown you how to do one-to-many between users and blogs, we did that for you. We're asking you to do this on your own, right? Creating a one-to-many between the post, the blog and the post. So you're gonna have to create your own post table, and you're going to create the one-to-many between the two. Okay, so post is gonna have to have a foreign key that points to the blog. Okay, and then we ask you to save the post table in a create post table SQL. All right, having done that, we ask you to, we're going to implement for you a many-to-many. A reply is going to be a reply between the user and the post. Right now, I don't have the post table, so let me create the post table real quick. And I won't do the whole thing. I'm just going to create, posts, and I'm going to have ID, and that's it. All right, I'll leave everything else for you. Right, that's all I really need. Apply. See, when you do apply, you have an opportunity to copy the create statement. See that? But if you forget about it, you can still get it later. Okay, there it is. So we created the post table, which is what you're going to do, right? So what we're going to do here is that we're going to create a many-to-many between the users and the posts, right? And there's a many-to-many, right? One-to-many and then many-to-one, right? So we're going to create a replies table. Again, it's plural, right? It's going to have its own primary key. It's going to have the actual text of the reply. It's going to have a link that points to the user and a link that points to the posts, okay? It still is going to have the create. It's going to have the update. Oops. It's going to have the create. It's going to have the updated, right? It's going to declare the ID as the primary key. Let's copy this. Let's copy this and let's bring it over. See if there's any errors here. Let's open up a new SQL. Let's paste that in there. Okay, looks like it doesn't have any syntax errors. Also, notice that the first line here, we have a drop table. See that? Drop table if exists. So what this allows me to do real quick is that, if I want to recreate this table over and over, right, while I'm playing around and checking to see if this works, okay, this allows me to remove the table, because if I try to create a table that already exists, I'm going to get an error. Right? So what drop the table does is that it checks to see if the table already exists, then remove it, drop it, remove it, and then create the table. Okay, so I'm going to remove this design. Okay, so again, the reply is going to have its own primary key. It's going to have the actual text of the reply, and also it's going to point to the user and a point to the post. Notice that I added an ID at the end. See that, an underscore ID. I believe I forgot to do it for the blog. Blogs is also pointing to the user, right? It's often a good practice to, if you know this is going to be a primary key, to know that what you're going to store here are IDs of a user, right? Because you're going to be referencing a user, right? And you're going to be referencing a post. Okay. So I'm declaring this primary key as this field a primary key. It's saying that the user ID here is going to be referencing the users here. Oh, I need to remove this, right? There we go. Oops, cancel. It's going to be referencing the posts, the ID. Okay, and if there's cascade, then delete it. Meaning, if you remove the user, it makes no sense to have the replies. Right? You should be able to remove all the replies if the user goes away. Or if you remove the posts, it makes no sense to keep the replies. Right? So remove also all the replies if the posts go away. Right? Now I'm concerned that when I created a table, that blog, I forgot to remove this users like that, right? So let me run this again. So I regenerated the blogs. Okay, there we go. I had a mistake here. It was pointing to the blog, the DB design, but I wanted to point to the current one, right? Same thing when I'm doing here, right? When I'm creating the replies, I'm going to create these references, right? So that references a table that exists in the same schema. I don't want to be pointing to some other schema, right? In the same schema. All right, so I click this, select the whole thing. Notice I'm selecting everything. Otherwise, these are two statements. These are two separate statements. There's a drop statement and the create statement, right? If you just execute, it will by default it'll execute wherever the cursor is, right? But if you want to execute the whole thing, you'll need to select the whole text and then run. Right, now it runs the whole thing. It creates the replies table. Let's refresh. There's our replies table. Okay, perfect. With all the columns. But notice that we're missing something, right? We're missing this little loop here, right? We're missing this little loop. And the loop basically is, it's going to be a field that references itself, right? But notice that I did not add it. The reason I didn't add it was that you cannot reference yourself until you actually exist, right? So if I had added here a foreign key that referenced the replies table, it would have failed. Right? It said, well, the replies table doesn't exist yet. Right? So how do we do that? How do we add later? How do we alter? How do we modify and add additional constraints? Right? So yeah, we could have done this. We could have tried to do this, right? We could have tried to add a field called replies ID, right? And then we would have said that this is a foreign key that references the same table, right? But that would have failed, right? So instead, we're going to use this command, right? We're going to use this command. It's an alter command. So alter command allows you to modify tables after they have been created, right? So for instance, here the alter table is going to add a column, call replies ID, that it should show after the post ID. See that? And okay, I'm adding an index. I don't really need to add an index, and then I'm going to alter the table again, right? And I'm going to add a constraint, right? On this column, I'm going to add a foreign key. I'm going to say that, hey, that column you just created called replies ID, it should reference the replies table in the DB design schema. And right, if you delete the parent reply, then all the children replies should go away again as well, right? So I'm going to copy that. And I'm going to add it. I'm going to add it towards the bottom. There it is, right? And so let me do this one first. Let me execute that one first. Run that. Notice that there's no reply ID here. See that? I'm going to add a replies ID. So let's select that. Let's run that. Oops. Replies ID. There's a question on the chat. Why do we need to alter twice? Well, because first we need to add the field and then add the constraint. Wait a minute. What? I got an error here. Let me check what's going on. There we go. Duplicate column replies. Oh, did I already have a replies ID? Oh, I know why. I'm adding it to the. I'm doing it in the wrong schema. Yeah. Let me remove this. Remove this, right? Because I'm working with the DB design 03, right? So let's do that. Let's run that. Okay, now it's okay. Notice if I refresh this, now I have the replies ID there. Perfect. But currently it's not referencing anybody, right? I'm going to now do this alter, and I'm going to run that, and it's going to add the constraint, right? So that it references, now it's a foreign key. Can we do it in one alter? I don't believe so. No, I think I was getting errors because you were trying to add a constraint on a field that didn't exist yet. All right, so once we've done that, we did the many to many, right? We did the many to many, right? Plus we added this little loop here. Now you try it, right? So what we're going to ask you to do is just like we did the replies, that replies between the users and the posts, right? Now we're asking you to implement a many to many of the ratings. Okay, you're going to create a table called ratings, and that creates a many to many between the users and the posts. On your own, do that and save it on the ratings table.sql. So at the end, you're going to end up with 6 files, right? You're going to end up with 6 files, creating the user, creating the blog, creating the posts, right? Creating, I guess this should be blogs, posts, table, replies, yeah, and whatnot. So yeah, use these names for the files, right? If I misspell the name of the file, no big deal, right? As long as what the content is proper. Okay, let's see, anything on the chat? What happens if there's a cycle in the table? Does a cascade lead to errors? No, basically what you do is that it just looks at your parent, right? If your parent is gone, right, then you delete yourself. And whoever has if somebody up below you is pointing to you, then again you point to yourself again, and it gets removed as a hierarchy. Okay, as a tree. All right, so wait a minute. So table, add replies, make sure these file names are correct. Replies, posts table, right? And this was blogs table, and this is a users table. Okay, that's good. All right, good. So there you have it. That's the third assignment, and go at it. Could you please repeat how to copy to your clipboard the code equivalent? So if you go here, right, and so for instance, if you go to a table, and you forgot to copy the replies, right? You can say reply, and then copy to clipboard the create. So it's copied, not in my clipboard. So if I click here and I do Control V for pasting, there it is. See that? Right. Or you could just say, copy, copy to the, or send to the SQL editor the statement. There we go. See that? It's right there. And then you can copy it. All right. All right. Good. So that's the third assignment. This will be due next Tuesday, right, at midnight Eastern time. All right. So let's now go back to the lecture. Today we're going to be covering, how is it that we chose these IDs, primary keys and foreign keys, and all these constraints. What do we mean by a constraint? Okay. So let's talk about all that. Let's go back and took a look at the slides. All right. Okay. Excellent. So let's talk about data definition. So we just finished designing the database, right? Being able to create the class diagrams and represent many-to-many, one-to-many, and all that, right? So now we want to convert that into actual tables, right? So tables. Right, remember, tables are how we represent data in a relational database. We have tables are going to have a whole bunch of rows. Each row is going to be representing a record. And then each record is going to have a whole bunch of columns, which we refer to as fields, right? And each one is going to have a data type, either an integer, character, date, timestamp, right? A float, whatever data types it supports, right? And so we've been looking at, in the example throughout the semester, we've been looking at this example of these tables, right? The students table, the department table, the course, section, and role, right? And with these primary keys, right? These are foreign keys that refer to the primary keys, right? And so now the actual implementation, when you have it implemented as tables, right? It will be showing multiple rows that reference each other, where you have a student referencing records in the department table, and you have the enrollment referencing other than a particular section, and the section referencing some courses because these sections are for that course. Okay. Now, a little later, we'll talk about normalizing the data. Somebody might have asked, well, why are we using so many tables? Why didn't we use one big table? One big table, right? And we could have just captured all of these fields in one single big table. Now, if you do that, what you're going to end up is with a lot of redundancy, right? Alice and Bob and Dan are all in the chemistry department. And so notice that you're copying multiple times the particular course that they're in, the department name and the professor. It's being copied multiple times. So instead of, for instance, copying the fact that Dan is teaching that section, if this were a separate table, we could have captured the professor only once, right, in the section the professor Dan and Ed, right? So as I mentioned earlier, when you have these redundancies, data being captured multiple times, you run the risk of inconsistency, and so we want to avoid that at all costs. Okay, so here's an example of creating one of those tables, right? So we said we have the student table, the department table. So how do we create the table? Well, the way we just did, right? We showed you SQL has a create table command, and then the name of the table, right? And then you have the fields in there, such as, for instance, the student ID or the student name, and we'll talk about that a little later. We're saying that student ID is an integer and it's not null. So whenever we say that you have a field, right, and you start adding these annotations here next to the field, we call these constraints. We call these constraints. By constraint, we mean we're telling the database to verify and make sure certain things are correct. Okay. If we say that SID is an integer, well, what we're saying, hey, database, make sure that the data that is stored in that field is an integer. We also, if we say not null, that's another constraint. We're saying that, hey, database, make sure that that field is not null, right? That whatever happens, if I try to update that field or insert that field or do anything, right, that you always verify that it's not null, right? So that whatever command I send you, if it breaks any of these constraints, stop me, right? So do some validation, right? Make sure that this is a varchar, that it's not bigger than 45, and that it's a required field. You better give me a value. So all these are constraints. We'll talk about much more about constraints in a bit. Null values. Now, null values in SQL means that we don't know the value, right? We literally means that I don't have a value for it. It doesn't mean, like in other languages, that that it means that maybe it's an empty string, or it's the value 0, or some special character. No, it means that literally, right, nobody has ever given us a value for that field. Okay, like for instance, if you're filling out a form, if somebody doesn't fill out a form, it means that that field for that form, it's null. We don't have a value, so it doesn't mean that it's left blank intentionally, and we should have an empty string in there, right? It means that we don't have a value. It's very important. We'll come back to haunt us later on. We'll talk about it a little later. So keys. So keys are used for these keys are special fields, usually fields that sometimes don't represent any real physical phenomena, right? Like for instance, your student ID, right? Your student ID is a key, okay, that uniquely identifies you within the context of a university, okay? And so in databases, it's very important to be able to choose the correct key, right? Most of the time, we're just going to be lazy, and we're just going to say, oh, it's just a field called ID, and that's it, and leave it at that, okay? But it can be a little more involved choosing those keys, okay? So for instance, let's talk about super key, right? So a key, right? We say that a key is something that uniquely identifies you, right? And so imagine we didn't have student ID to uniquely identifies us in the university, right? We might say, oh, well, what about last? We're trying to verify and choose, what can we use to uniquely identify us? And say, well, how about your last name? And you say, well, okay, well, my last name maybe is unique enough within a a small context, maybe within in a section, right? Maybe our last names are indeed unique within our section, right? But then you find that there are two folks that actually have the last name Smith, and they say, oh, well, that doesn't work, right? My last name is not a good key to uniquely identify me. How about we add additional keys? How about the first name, right? And says, oh, well, that would make us maybe more unique, and maybe within the section, the combination of first name and last name is unique enough, and then we realize, oh, there's another person also called Jose Annunciado. How crazy is that? In the same section, and it says, okay, well, what about if you put the middle initial? Does that make us unique enough, right? And says, well, okay, yeah, maybe that's true. And so within our context, that's true, right? Now say within the context of the section, the first name, the middle initial, and the last name, the combination of those three fields makes us unique, right? So we call the combinations of keys, right? We call them super keys, right? It's the collection of all the fields, of any of the fields in a record that make us unique, okay? Now, what if I add, what if I say the first name, middle initial, and last name is unique enough within our section, okay? Would it help if I add another field, maybe an email? Would that make us more unique? Probably not, right? If the three fields, first name, middle initial, and last name, makes us unique within the context of a section, adding email probably doesn't make us any more unique. Okay, so the definition of a key, right? A key is a super key, right? Meaning super keys are all the combinations of all the possible fields, right? So we say that the email is superfluous, right? It's a field that doesn't make us any more unique, right? We don't need the email or password or whatever, any other field to make us more unique, okay? So we say that the key is the smallest set of fields that we need to make us unique within a context. That makes sense? So a key, we say, formally we say that a key is a super key with no superfluous fields, right? In our case, for our table, the students table, SID is plenty, right? That makes us unique enough, all right? Now so we have to make sure that when we choose the fields as our key, that we select it based on our understanding of the fields that we're choosing. Okay, so for instance, not from the data that we might look like. Say somebody gives us some sample data, and we realize that one of the fields in the sample data, it doesn't repeat. Right? We see that we see this column, we realize that it doesn't repeat. Right? Maybe it's some sample data in a small section like ours. Well, ours is not so small, and we realize that, hey, everybody has the last name field, right? No, it doesn't repeat. So you might decide that choosing the last name as a field, you could conclude that the last name would be a good key, right? Because it doesn't repeat. Now, your conclusion is based on looking at sample data, and that's wrong. You should never use sample data as a determinant on whether that is a good key. Instead, it should be based on what your understanding of a last name is, right? You might say, well, no, last names, it must be that we got lucky, right? That in this section, nobody has the same last name, right? Probably that's what really happened, right? We just got lucky that nobody had the same last name, right? And so, but we might not get as lucky next time. So you should conclude that last name is not a good key, right? Not because don't base it on the data, base it on your understanding of what the fields are. Make sense? Also the keys, right? The keys might be useful for enforcing certain constraints, certain logical constraints, right? So for instance, in our enrollment table over here, right? This one, the enrollment table, we talked about earlier that we might want to enforce the fact, right, that a student should not be able to enroll in the same section twice. Okay, and the way we could do that is by, for instance, removing that old key, right, and instead making here a compound key, right? We can say that this here, the combination of both the student ID and the section ID, that makes us unique, right? And because it's unique, that means that we're not going to allow the same two combinations to be inserted into a table. Okay, let's see, is there a question on the chat? So does that mean the last name, first name can't be keys? Again, it depends the context that you're talking about, right? And no, I don't believe it would be a good set, a good choice, right? Because you might just get lucky that within a university or within a section, two people are not going to have the same last name, right? We could have for instance, in certain cultures, right? There are certain names that are very, very common, like Jose, right? In my culture, is a very common first name, and Maria and whatnot, right? So those are very common first names. And it might be that certain last names are also very, very common, right? So it might be the case that in your little sample data, you got lucky and there was no Jose Hernandez, right? Those are two very common first name and last names. And so it might be the case that we have several with the same first and last. So no, it would not be a good choice. So many folks don't bother to even select a key. Many database designers are just going to say, you know what, I'm not going to bother that. I'm just going to choose an artificial key. That's why you see folks, it's so prevalent that folks, us as human beings are associated with so many primary keys, so many artificial keys. I have, all my credit cards. Those are all artificial keys, right? My social security number, my student ID, right? My license plate, my, all my phone number. We are inundated as human beings with tons and tons of these artificial keys. Are there any downfalls of having artificial keys? Just basically understanding, folks, and the lack of mapping to some physical phenomena. No particular downside. No, they're very useful for indexing, right? For hashing, especially if you understand what the algorithm is to generate these keys. You can make it very useful for improving performance. So yeah, no downside. All right, keys, selecting keys. All right, so these are just some examples of certain constraints. So duplicate records, yeah. So here we have been adding these primary keys, and we have been adding. We've been implementing using this primary key over here. See that? But SQL actually doesn't force you to do that, right? SQL doesn't mind you having two records having exactly the same values, right? And or 3 or 4 or 5 records having exactly the same value. Now the problem with that, right, of allowing you to do that is, what if you want to update one record or update another record? Because the values are identical, SQL, there won't be any way for SQL to be able to distinguish one record from another record. Okay, if you say, update the salary for an employee whose first name is Joe, but then you have another 3 records of folks with the same first name Joe, how is it going to identify which one do you mean? Right, all Joes are going to get a raise, right? You're going to improve a salary. So if there's nothing yet you can grab onto the record to know which one you mean, right? Then they're indistinguishable, and they'll all be treated as one. So if you update one, they get all updated, right? If you delete, they're all going to be deleted, right? So it's very important that we add primary keys. So primary keys is how we make sure that something is unique, right? Well, actually, no. You can. There's another constraint called unique, right? Unique, which forces a field to be unique, but not necessarily primary key. Okay, so primary keys adds at least 2 constraints. One is that it's unique, right? Meaning that you cannot enter 2 records that have the same value for that field, right? So for instance, if you try to insert a replies that has the same ID, right, the database is going to stop you. It's not going to let you do that. It says, there's another record with that same ID value. Okay, but it also primary keys not only makes things unique, but it also prepares this record to participate in relationships with other records. Okay, right? Remember, we have the blogs. Where's my blogs? What happened to my blogs? Columns, right? So the blogs, right, are referencing our users. Yes, and so that means that blogs, right, are going to have a field user, right, that is referencing the primary key of the users column, right? This one, this ID. Okay. Now, if I say that this ID is not only unique, but it's a primary key, that means that if I have a foreign key, this user here is referencing this ID here. Now there's going to have a special relationship between the two, right? The database is going to enforce certain things, right? One of the things is that it's going to enforce is the fact that, if I have a blog that is pointing to a user, okay, what happens if I delete the user? Well, if I delete the user, then if I allow you to delete the user, which this blog is referencing, then the blog is going to be left hanging there, right? Referencing a user that doesn't exist anymore. Okay, so we call that referential integrity, right? The fact that I'm not going to allow you to remove the user if there's a blog referencing that user, right? That means that I want to maintain referential integrity, right? That I don't want to leave the blog hanging, right? I don't want the, you know, if you look at it as a parent-child relationship, right, where the user is the parent of all the blogs, I don't want to leave the blog orphaned. Okay, I don't want to use the blog pointing to something that doesn't exist. Okay, so it's just like, for instance, just like in file structures, if you have a directory that has files, if you try to remove the directory, the operating system is going to stop you and say, sorry, but that directory is not empty. Right? You have a whole bunch of files in there. Okay, I mean, you can force your way through that, but you know, in the same way, we don't want to delete children. We don't want to delete parents if there are children associated to those parents. Okay, so primary keys enforce that enforce that referential integrity. Okay, so the way we do that is that we declare the field, right, and then we declare a primary key on that field. So foreign keys, right? So foreign keys are going to be fields that are going to reference other fields, right, in some other table, right? And that, like we did for blogs, referencing users, posts, referencing blogs, yes. And the way we do that, the example that we're looking at is major ID, department ID. All these are referencing our foreign keys to the departments and the courses and the students. Okay, see in the chat. Should tables that are used for reifying have primary keys? Well, yeah, that's a good question, right? So for instance, in our case, where we implemented the replies, right? So replies and I think replies and reviews, I believe. Here we have two fields. We have user ID and post ID. So one thing that we could have done, instead of having this ID, we could have made these user ID and this post ID a compound key, where the combination would have been the primary key, as opposed to using this ID as a primary key. Okay. Now, what this would allow us to say is that the same user, right, cannot create a reply to the same post. Well, actually, wait a minute. Maybe I don't want to do that, right? Because if I make that a primary key, then I'm saying that you can only reply to a post once. One user can reply to the post only once. And is that so? Probably not. I don't want to enforce that. I should allow the same user to reply to the post multiple times. So no, in this case, I don't want to make a compound key out of these two, and so I'm going to leave alone this primary key alone, right? Okay, so I'm going to keep that primary key. So in this case, no, I do want to keep the primary key. In the enrollments case that I mentioned earlier, that makes sense not to use a primary key and instead use the two fields for as the primary key, as a compound key. So, but not in this case. So to create the foreign key, here you have the departments table, and then the user and the student, right? It's going to create a department field that is going to reference. It's going to reference the department, right? DID department. Okay. All right. Excellent. Okay. So schemas. So schemas. Remember, schemas mean that it only means structure of the data, right? How are we establishing the structure of the data? And in class diagrams, we use classes, right? The classes to specify the the fields, the data types, and the relationships between the classes. In relational models, we use tables, right? And so we're going to try and follow this nomenclature, right, where we have the tables are all caps, the primary keys are underscored and capital and bold, whereas the foreign keys are italic, right? But they're not underlined, and they reference a primary key of the same name. Keys and the foreign keys connection, right? So these foreign keys and primary keys allow us to navigate from one record to another record, right? Follow, these pointers, right, that are referencing each other, right? Navigate the data structure. Reference integrity I mentioned earlier, right? If you try to remove the parent, we're not going to allow you because there are children involved, and we should be able to specify what should happen if you remove the parent. What should happen to the children? By default, if you don't say anything, which also means no action, right? You can configure it explicitly, no action. By default, what happens is that you're not allowed to remove the parent when there are children pointing to that parent, right? But you can configure to happen something else other than the default. You can say that, say that you have the department and you have two students referencing the department, right? What happens if you remove the department? What should happen to the student? What should happen to these foreign keys that are pointing to that department? Okay, you could say, well, don't allow it. You can't remove the department if there are students pointing to it. Or you can say, well, if you remove the department, then replace these values with null, meaning now the students are not pointing to anything. At least they're not pointing to the wrong department, right? A department that doesn't exist. At least they're pointing to null, and I know that these students haven't yet, decided what department they want to be in. Okay. Or what about if I change the value from 20 to 21, right? Well, I can. The default is that I don't allow you to do that. You can't change that because I have folks referencing you, right? Or I can configure it to cascade, right? So that if the value changes here, then it cascades to the children, right? So if I change it from 20 to 21, it cascades. The update cascades to the children, okay? Or that if you have remove, right, this record, if I have children referencing it, I can cascade, right, those deletions, those removals to the children, right? So those cascade actions, right, you can cascade the update, you can cascade the delete, right? There's a few cascade actions that you can saw it in several of these, right? We can configure, there it is, see that? To configure and say that if the blog, right, the blog references the user, right? And here's the foreign key, there it is. And here we have configured that if that foreign key, if the value of the primary key changes, right, I'm referencing you, well, cascade the update, right? If it changes from 30 to 32, then also change the value of this field. Or if you remove the parent user, then you cascade the delete. So delete, right, also this record if my parent record is removed as well. Okay. Yeah, so you have cascade actions. So constraints, we've been looking at all these types of constraints, right? Want to make sure that there's referential integrity constraints, right? That that they're unique, right? That they're not null, right? So all these are various types of constraints. Okay. So specifying tables, right? We're going to be using the create statements that we have been showing you, right? Create, and these are just examples which you're going to practice in the assignment. Okay. Any questions? All right, so let's continue. Relational models. Okay, that's just an example. We'll talk about that a little later. Okay, so all right, so let's talk about views. So views is so we have tables, right? We have tables. And now sometimes tables are somewhat inconvenient for some users of the database. Okay. So for instance, we have made the decision when we were designing this table, we made the decision to choose these tables, right? To split it into multiple tables, right? That was part of the design process. Okay. Now, depending on who the end user is that wants to use this data, it might be very inconvenient to have the data so split up into multiple tables. Okay. And so it might be more convenient for them if we had the data all jumbled up in one single table. All right. And so the so depending on who the audience is that's going to consume this data, we might oblige them and say, okay, fine, I split it up into all these tables, and it's very inconvenient for you. So let me create. So the wrong thing to do would be to say, you know what? Instead of splitting it up into these 4 tables, let me make a big table for you that has all the values in one single place, right? All the records and all the columns in one single place. That's a no-no. You should not do that, right? We suffered a lot, deciding to split it up into multiple tables now to screw up our design. Okay. But nevertheless, we would like to see if we could help them out. Okay. So for instance, somebody might want to say, you know what? I want to see all the posts across all your blogs, right, for a particular user, right? Because I want to, I'm an editor and I want to go through all your posts, right? I want to do, copywriting. I want to make sure everything's spelled correctly, and I don't care if your posts are for this blog or for that other blog, right? That's you, right? For you, you want to maintain, some marketing for your space related blog, and you want to create some other marketing for your car related blog, right? But me as a copy editor, I don't care about your marketing. I'm just going to do some validation of the text, right? If you spell everything correctly. So ideally, you would give me a table that contains all this data, so I don't have to retrieve the data from both tables. Very inconvenient, right? So how do we do this? So what can we do? So what we can do is that instead of creating a table that is going to be very redundant, right? We can combine the tables into what is called a view, right? A view. And notice that we have here a view. See that, this view? So views are almost like tables, right? They look like tables, they behave like tables. Well, not entirely, right? And so they have all the properties of tables for when you retrieve data, right? When you ask for data, right? And you can treat them just like tables when you retrieve data. Okay. But actually, you know what? I don't want to get into it too much just yet, because we do need to learn about retrieving data, and we haven't talked about retrieving data just yet. Okay, so let's table views for now. Table views. Pardon the pun. Let me cover that just a little later, right? Let me take a look at relational models. Just make sure that we have covered all the material here. Right, we know how to create one-to-manys, right? Creating tables, for instance, this website, right? If I've captured here a couple examples on how to graphically create different tables, right? And also add the current timestamp and the on-update current timestamp. So these are a couple examples on how to do the create and the up, and you can see the actual SQL that gets created, right? And even some examples on how to insert a couple of pieces of data in there, right? So let's see. Create the table pages. Oh yeah, so here's also a couple of other examples on notice that this is implemented as a composition, right? Meaning that if you've removed the left-hand side, right, we're also going to remove the right-hand side. So we want to cascade, right, the deletes on the parent, we're going to cascade it to the children. So how do we do that, right? So you can click on a foreign key, you can select the foreign key, and you can cascade that, right? So here, for instance, if I go and I take a look at the blogs, right, the blog, and I can alter it, right? You'll notice that the primary key, foreign keys, right? These two, this user is a foreign key. Okay, so if I click on the tab foreign key, you'll notice that the way we created the foreign key was to first we need to give it a unique name here for the foreign key, and this has to be unique across the entire schema. Okay, oftentimes it's useful to just generate a random string here. Okay, and then say, well, okay, well, what table are you referencing, right? And you can select here, what from the schema, which table are you referencing, and that's the table that this blog is referencing. There it is, and then it shows you here all the fields in your table, right? The name, the topic, right? They created, and there it is. I selected user, and then here it lists all the fields of the other table that you're referencing. Who are you referencing? I'm referencing the users table, right? That's the users table. So these are all fields from the table that I'm referencing, right? And what am I referencing? I'm referencing the primary key. I'm not referencing the first name, the last name, the username, the password. I'm referencing the primary key, right, of that other table. Okay, and here I can specify graphically. I can specify that if the primary key of the reference table changes, meaning it's updated, I want the update to cascade and change my user foreign key, right? Also, if the record that is being referenced is deleted, I want it to cascade, right? And so that it's going to also delete the record that I'm in. By default, the default is restrict. Is restrict, okay? Or I can cascade, meaning that if the parent is removed, the child is also removed. Or I can set it to null, meaning I'm no longer pointing to anything. Or no action, meaning will allow it, right? I will allow it, but I'm going to keep the old value, right? I'm not going to change it. I'm going to leave it alone, right? And I'll be pointing to something that no longer exists, right? So by default is restrict, meaning don't allow it. Don't allow the deletion. Okay. Same thing for the replies, right? If you look at the replies and we look at the alter here, right? There it is. We have the user ID and the post ID, right? And we can take a look at the foreign keys for each one of them, right? I have 3 foreign keys. One of them is referencing the post. One of them is referencing the self replies, and the other one is referencing the users. Okay, oops, sorry, I didn't mean to do that. Revert. And if I select it, notice that here I can configure each one individually, right? So this one is replies. There it is. I'm configuring my replies. Configuring my replies foreign key, and it's referencing what? It's referencing myself, right? So I'm referencing the primary key in the same table, whereas this one is referencing the users table. So the user ID is referencing the fields in the user table, which are first name, last name, or the primary key. And the post is referencing the post table, right? And so it's saying that I'm referencing all the fields in the post. And notice that there are no other fields because this one you're going to create on your own, right? Which is going to have a whole bunch of other fields, and they're going to be listed here. And notice that all of them, I'm using cascade, right? On the update, cascade on the delete, meaning that if the parent is deleted, then it's going to propagate to the other records. Okay. So anyway, here I just took some snapshots and explain on how to do this on your own. Okay. Right. So let's talk about normalization. Let's talk about normalization. All right. So normalization is a topic about why did we split the tables in the first place, right? And why didn't we leave it in one big table? Okay. And usually the reason is because we're trying to avoid redundancy, right? Remember that in the example I showed you earlier, what if instead of having students and departments and enrollments and sections and courses all in separate tables, why don't we have it all in one big table? Well, because we're going to have a lot of redundant data. Okay. Now, what are the principles by which we decide to split one big table into two tables or three or four or five, right? So this is what we're going to study. So normal forms, right, studies the various types of redundancy that we're trying to avoid, right? And how is it that we're going to decide to split it? Okay. So yeah, so normalization is the act of splitting up bigger tables into smaller tables so that the data is not redundant. Okay, so to minimize the redundancy. So there's just a couple of types of redundancy that we want to avoid, right? And so there are three main scenarios where redundancy can appear. So let's take a look at each one of these. All right. So first, let's talk about what is called first normal form. Okay, first normal form. So first normal form is, one of the ways that you can fix one type of redundancy. So let's take an example. Imagine we had the following table, right? And you have, these might be customers where you might have, first names and last names, right? And you have phone numbers. Yes. Now we might have made a mistake on deciding on how were we going to capture these telephone numbers, right? We thought maybe people were just going to have one phone number. And we realized that some folks, have more than one phone number. And so we find ourselves in a bind, right? So what should we do? What do we do with two phone numbers, right? So one might decide to say, oh, that's easy. I'm just going to use that same field and I'm just going to make it plural. Instead of telephone, I'm just going to be telephones, right? And I'm going to store the phones in that one field. And I'm going to use some, either a comma or a bar or some mechanism where some special character that I'll know that I can split it later on. Okay. And so this is a typical case, right, of first normal form redundancy, right? We don't want to do this. Fields should capture only one piece of information, right? And that's it. Okay. You should not have multiple types of information in here. This is not one phone. This is multiple phones, right? The alternative might be to have maybe multiple columns where you capture, the first phone number and then the second phone number. So that's another alternative. But this one also is not very good because it doesn't scale very well. Okay, what if you have three phone numbers? What if you have four phone numbers, right? So one might say, oh, that's fine. I'll just make 10 telephone numbers. I mean, nobody's going to have 10 telephone numbers, right? And what you'll probably find is that folks might have maybe on average 1, 2 phone numbers, maybe 3, and usually, the other 7 phone numbers will be null most of the time, right? So this is kind of like over designing something for something that it's very unlikely to happen, right? And you have all this wasted space of just null everywhere, right? And this is very bad for performance, for data storage. This one's very bad for data retrieval, right? That you have multiple phone numbers in one column, because when you retrieve, it's very hard to compare. If you're looking for somebody by their phone number, right? How are you going to look for a phone number if you have two phone numbers in there, right? You're going to have to do string manipulation and and parsing the string. It's very expensive. So no, that's not a good optimal solution. So what other solution do we have? We'll say, well, what about if instead I just copy, I have one record, one individual record, so that I can maybe have multiple phones, right? And I'll just have the other fields just repeat themselves, Billy Squire and Billy Squire. And again, notice that this introduces redundancy data there, right? That is being captured multiple times, right? And it could be inconsistent. I could inadvertently update this record to be William. That maybe logically means the same thing, Billy and William, right? It might be logically means the same thing, right? But they're not, right? So I could mistakenly have update one but not the other. Chat, create a phone number table with CID. Yeah, that's exactly what we're going to do. Like your colleague here was suggesting, to fix this, right? We're going to split this original table, right? We're going to split this original table into two tables, right? Two tables where we're going to have a table dedicated to storing only telephone numbers, right? And we're going to have a foreign key that points to the other part of the data. So we're going to have the customers on one table and then telephones in another table, right? This splitting, because we want to avoid redundancy, is what we mean by normalization. We are normalizing the database, right? So if you ever find in your professional experience either something like this or like this or like that, right? You're gonna tell your boss saying, hey, your data is not normalized, right? And I can normalize it for you by splitting it into multiple tables. Make sense? All right, so now we have normalized it. Now we say, right, that this database schema meets first normal form, because we're fixing a specific type of mistake. All right, so let's look at another one. Let's look at another example. So first normal form, definitely good, but it's not enough, right? There might be other types of redundancy, right? Other types of let's look at this, right? So second normal form deals with keys, primary keys that are compound keys, right? So for instance, here we have a key, CID and semester, which are compound keys of this table, right? So meaning that the combination of these values is unique. I'm keeping track of courses on the left-hand side here, and I'm capturing the semester here on the right-hand side over here, okay? Now, we see that these fields on the other side here, right, are not keys. So they're not primary keys, they're not foreign key, they're just, they're just keeping track of data, right? How many seats, how many the course name and whatnot. Now, we notice that some of the data here, right, like this column over here, looks like it's very related, looks like it has a very strong correlation with the course, right? So programming is the course name for CS1500, and databases is the name for the CS5200. See that? So there's a strong correlation of this field with this field over here, but not with this field, okay? Regardless of what the semester is, the name of the course is the same, right? So basically what's happening here is that your field has a dependency with half of your primary key, but not the whole primary key, right? And that's a no-no. Okay, that's a no-no, right? Fields should have dependencies, or should have a strong correlation with the whole key, right? Right? And so let's look at an example. How could we fix this? The way we could fix this is by splitting this big table into two tables, right? We split it into these two tables where instead of keeping track of the course right? In this bigger table, we're just going to split it up into another table where we keep track of all the courses. And one of the fields is going to be a foreign key that references the primary key of some other table, right? So now all your fields that are left over depend on both on the entire key, on the entire primary key. So 1500 this particular semester had 100 seats, and 5200 in this semester had 200 seats, but 5200 in some other semester had a different set of seats, right? Which is perfect. The seat depends on the combination of the course and the semester. So all your fields in the table should depend on the entire key, okay? And so here, course name here depends on the key. It's perfect, right? That's what we want. So here's another example. We have here an employee table that has employees and skills, right? So we have Alice here has the skill of QA. Alice has CSS. Alice has the skill HTML. It would make no sense for Alice to have the same skill twice here, right? So we make it into a compound key that Alice, the combination of the two is unique. Make sense? Okay. Now, Alice, we're also capturing here the fact of where is this employee working? And Alice happens to be working in Cambridge, right? And Bob in Newton, and also Charlie and Dan, they all work in Newton. Now notice that this location of where Alice is depends only on Alice. It would make no sense for Alice to be in two places at the same time, right? So if you're talking about Alice, then you're talking about Cambridge. If you're talking about Bob, then definitely you're talking about Newton, okay? So notice that it is irrelevant that Alice has a particular skill for which she'd be in Cambridge, right? She's only in Cambridge because she's Alice. Make sense? So again, this breaks second normal form, right? It breaks, so it does not meet second normal form. Your fields depend on half the key. And the way we fix it, right, is that we split it into multiple tables, right? Instead, we're going to have here a table where we keep track of the location of each employee, and then we can use these employees as foreign keys to the primary key of the other table. Make sense? Right. And we'll introduce, we'll see that even if form, right, we see that there might be some problems, right, still lingering. So we'll make the case that second normal form is not enough, right? And that's why we're going to be talking about third normal form in the next lecture. Right? Third normal form will finally make sure that our database is normalized. Okay. All right, folks. That's all I have for you today. Let's convene on Friday, and we'll finish up database, creating databases. All right. All right. Excellent. Thank you.